right, hello everyone. This is sprint number 23. So let's have a look at a problem that hopefully all of you had a look at just a few minutes ago. Ollie chooses a non-empty subset of the positive integers from 1 to 10 inclusive. He notices that all of the numbers in his subset are relatively prime, which means that no two of them have any common divisors greater than 1. How many different subsets could Ollie have chosen? Okay, so we're looking for a bunch of numbers that are relatively prime. My first thought is primes are usually relatively prime, right? In particular, 7, which is between 1 and 10, that's relatively prime to everything from 1 to 10, right? Because the first number that's not relatively prime with 7 is 7 times 2, which is 14. And then the other thing is 1, that's relatively prime to everything, because it doesn't have any divisors greater than 1. So how could it have a common divisor greater than 1 with something? Yeah, those are the numbers from 1 to 10. You guys know those. So 1 and 7, those are kind of special numbers because they're relatively prime to all of the other numbers, meaning they can be in or they can be out. We don't care. We can get rid of those. And now we only have 8 numbers to think about, which is way easier. Now let's just do cases. I hate doing cases, but I think it's the move for this. So suppose the smallest number in Ollie's set is 2. Then we can't have 4, we can't have 6, we can't have 8, we can't have 10, right? Because any even number not relatively prime to 2, so those are out. That leaves 3, 5, and 9. Okay, we can't have both 3 and 9, right? Because those are both divisible by 3. They are not relatively prime. So we can have 5 or not have 5. And then we can have 3, or we can have 9, or we can have neither 3 nor 9, but we cannot have both 3 and 9. So we've got 3 choices for 3 and 9. Neither 3 nor 9, just 3 or just 9. And we've got 2 choices for 5. We can have it or we cannot have it. So that's 3 plus 2, that's a total of, 3 times 2. Because we can combine those. That's a total of 6 subsets that start with a 2. Okay, suppose the smallest number is a 3. Then we can't have 2 because it's smaller than 3. We can't have 6, we can't have 9 because those are both divisible by 3, which means we've got 4, 5, 8, and 10. Okay, and this is a little bit tricky. So if we put a 10 in there, that's divisible by 2 and 5. So that's not relatively prime with any of these other numbers. If we put in a 10, that's it, no more. We could put in 5 and 4 or 5 and 8, but not 4 and 8, right? Because 4 and 8 are not relatively prime. And then we could just put in 4 or 8. I don't know why that says and or. Well, that's because I typed it, but I was wrong because those are not relatively prime, so we cannot have both of them. So we can have 10, we can have 5 and 4, 5 and 8, or just 5. We can have 4 or 8, or neither 4 nor 8. So that's a total of 7 cases. I think that's the worst one. I think it gets better from here, right? Because as the numbers get bigger, if that's the smallest number, we've got fewer options for the other numbers, right? Like if 10 is the smallest number, that's going to be easy to think about. Anyway, if 4 is the smallest number, that rules out loads of stuff because we can't have anything else even, meaning we can have 5 or 9. 5 and 9 are relatively prime, so they don't interfere with each other, right? We decide whether we have 5, that's 2 choices to have 5 or not. We decide whether we're going to have 9, that's 2 choices, to have 9 or not. 2 times 2 is 4, so 4 choices. It's easy. If 5 is the smallest number, we can have 6, 8, or 9. So this is again the kind of complex one because 6 is not relatively prime to 8 or 9. Meaning if we put in 6, that's it, can't have anything else. If we put in 8, we can also have 9. So we can have 8, we can have 9, we can have 8 and 9. And then we can also have, 6 or not have 6. So that's 5 choices. If the smallest number is a 6, we can't have an 8, we can't have a 9, we can't have a 10, right? Because 8 is even, 10 is even, and 9 is divisible by 3. So if we have a 6 as the smallest number, that is the only number. What do we have? 8 is the smallest number. We can't have the 10, we could have the 9, or we could not have the 9. That's 2 choices, right? 9 or not 9, so that's another 2. And then if 10 is the smallest number, if 9 is the smallest number, we could have 10 or not have 10, another 2 choices. And if 10 is the smallest number, that's the only number in the set, right? Because it's the biggest of all the numbers. That adds up to 28. So is that the answer? That is not the answer because we cannot forget the numbers that we put in bold at the top of the screen. So we've got to multiply this by 3 choices. We can have 1, we can have 7, or we can have both, 4 choices. We can have 1, 7, both 1 and 7, or neither 1 nor 7. That's 112. And then a little sneaky thing we need to remember at the end is we have some subsets that don't include any of these numbers other than 1 and 7. Those are just 1, just 7, or 1 and 7. We can't have neither 1 nor 7 because then there would be no numbers. And it says right here all it chooses a non-empty subset. So that's an extra 3 cases, giving us a total of 115. And that is the correct answer. So if you put that, congratulations.
This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.